Hi there everyone, it's Penelope. This is FS 3128, this is topic 10, and this is the final class in our differentiation topic 10. We're only touching on differentiation very, very lightly in this course. You will do more if you come back and do the diploma, but what we're going to look at in this class is how we deal with differentiating something that is a product. So something times something, or how we differentiate a quotient, where it's something over something, and how we differentiate a function within a function. This is the technical stuff. If u and v are both functions of x, then the derivative is u dash v plus uv dash, and that's probably the easiest way to remember it there. And it doesn't really matter if you learn it in a different order, because both multiplication and addition are commutative, but it does set you up for being in the right space further down the track if you continue on your maths. Now, the big thing is to remember you need to use the rule. So you need to use the rule. You can't just differentiate each bit and multiply it together. That doesn't work. Now, for those of you that are ready to do your homework, the chapter 34 is in the earlier edition. If you've got the later edition, it's chapter 35, so this would be 35.2. So let's look at these examples. I'll do them on the next slide because there won't be enough room here, but you'll see exactly how the product rule works and how I want you to set them out. Here are 3 examples that demonstrate the product rule. First up, we need to find that u is just the first function. So that's u, what we call u. It doesn't matter. Some books will call it different things. It doesn't matter. That is u, and the second function is v. So following the product rule, if y is equal to x squared sine x, then the derivative is equal to u dash v plus u v dash. So we need to find u, we need to specify it. U equals x squared. And I want you to set it out like this every time you do one of these. Now find u dash and v dash. And then the derivative is u dash times sine x plus u cos x times v dash. You don't need to do anything else. That's it. It's done. For the second example, let's write out that u equals e to the 2x and v equals cos x. So u dash equals 2e to the 2x and v dash equals negative sine x. So straight away we can write the derivative as being u dash times cos minus, it is plus, but because we've got a minus sign, so we can say minus e to the 2x sine x. And you could simplify, you could take out a common factor of e to the 2x, but it doesn't matter, that's fine. For the third one, let's call u as the first function, and v is then natural log of x. U dash is going to be 1, and v dash is going to be 1 over x. So then our derivative is u dash v, so it's 1 times natural log x plus x times 1 over x. And you can do a little bit of basic simplification for this one and write it as natural log x plus 1. In the same way as we need a special rule to be able to differentiate a product, we need a special rule to deal with differentiating a quotient. And if you remember, a quotient is just a fancy word for division. So again, if you set it out in the same way, the rule is quite easy to apply, but you just need to remember that anytime you have a division sum that you need to differentiate, you must use the rule. I'll do these problems on the next slide, but for those of you that want to go and do some work in the earlier edition, it's exercise 34.3 or 35.3 in the online or later edition. Here are 4 examples of quotients, division sums, that we're being asked to differentiate. So the same setting out as before, only this time u is the top function, so u equals x squared, v equals 2x plus 1, finding u dash, and finding v dash. So now we can just apply the rule. So the rule says u dash v, so 2x, now keep a bracket around the next bit, 2x plus 1 minus u, which is x squared, times v dash, which is 2, all over, and this is the really important thing to remember in using this rule, that it's v squared on the bottom, so we simply write 2x plus 1 squared, and pretty much we can leave it as that. We could do a little bit of fiddling if we wanted to, but at that stage it is correct. For the second one, u, the top function, is sine x, v is the bottom function, so it's u squared, so u dash is cos x, and v dash is 2x. So now we can use that straight into the formula. So it's going to be u dash v, so it'll be cos x times x squared minus sine x times 2x all over, excuse me, I'm going to sneeze, whoops, all over x squared squared. And again, there's some simplification that you can do, but right now we're not bothered with that. Okay, I'm going to have to make a little bit of room down here. So for the third one, u equals x plus 1 and v equals x squared plus 1. So u dash equals 1 and v dash equals 2x. So our derivative is equal to u dash v, so that's just x squared plus 1 times 1, but I don't need to write that, minus u v dash, so it's minus x plus 1 times 2x over v squared, and keep it together, x squared plus 1 squared. Leave it like that. Don't be tempted to do anything else. At this stage, that's fine. For the last one on this slide, u is the top line. And v is the bottom line. So u dash is, now what's the derivative of e to the x? It's e to the x. The derivative of x is 1, and v dash is cos x. So using the formula, we have u dash e to the x plus 1, and since it's got more than 2 terms, put brackets around it, times v minus e to the x plus x times cos x all over v squared, like that. And just leave it like that. There is some simplification we may be able to do, but let's not. Let's just leave it like that. There's a third technique that sometimes we're going to have to use that none of the others work. We might have a function that says y equals 3x plus 4 cubed. Now we could do that by multiplying it out, but it might take us a while. So we need a rule that deals with this. This is kind of a function rule. And so this is the fancy way, and the fancy way is shown on the slide. But it's easier to talk your way through this and do it by talking, or almost, as one of my colleagues calls it, call it the cover-up technique. So let's have a look at some of these examples that will fit this rule, this technique. Right, the paragraph at the bottom of the page doesn't quite apply. Certainly test 10 is due, but it's not due on the date that it's given there. Exercise 34.4 is in the earlier version of the text. If you have the later version, it's exercise 35.4, and the page number is 460. Okay, now let's talk about this. Let's talk our way through. We can go straight to finding the derivative using the chain rule. We can't use the product rule because it would take us too long. It's not a quotient, so the only other rule or only other technique we can use at this stage is the chain rule, which we can also call the cover-up rule. Now, I'm not going to be able to demonstrate exactly this on this slide because I want to be able to put my finger on something, but it's where we find the derivative of the whole. We pretend, put our finger over the bit in the bracket. So it's the derivative of the whole. So we'd say 3, now my thumb's over that so you can't see it, 3 bracket squared. And now we differentiate what's inside. So we multiply it by the derivative of the inside. I just need to fill that in, what was covered in my finger, and there's your answer. So it's kind of like we differentiate the whole, it's the derivative of the whole times the derivative of the inside. So we're covering up the whole, covering up the bit in the bracket, differentiating it as a whole, and then multiplying by the derivative of what's the inside. So this one would be 3 bracket to the power of 2 times the derivative of what's inside, which is 6x plus 4. Go back and fill in what we'd covered up. And we're done. Same with the next one. The derivative is a half times the bracket to the power of a half minus 1, which is negative a half, times the bracket, the derivative of the bracket, which is 3. Put in what we'd covered up, and we're done. Well, you might want to say that's 3 over 2 times 3x plus 4 to the power of negative a half. That's fine. Now, the last one, before we actually do it, we need to rewrite it as something to a power. Now we're ready to go, because we can say it's a half times x cubed plus 4x to the power of negative a half times the derivative of what's inside, which would be 3x squared plus 4. So it's the derivative of the whole thing times the derivative of what's inside. That's a very brief look at the chain rule